Okay, so hi everyone. Today we're going to solve this problem, that is the merge k sorted list. It's LeetCode 23 and it's a hard problem, and it's a very classic and a very standard problem. It has a very good, as you can see, like to dislike ratio. Just a second. Yeah. So this problem says that we are given an array of k linked lists that is named as lists. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. So for example, this is the case, right? We have 1, 4, 5. Then another list is 1, 3 and 4. And another list is 2 and 6. Right. So if we, this is a linked list, right? 1, 4, and 5, this is a linked list. Then we have 1, 3 and 4, this is a linked list. Then we have 2 to 6, this is a linked list. Now if we want to keep these elements, so question says that you need to return me a list which is sorted and have all these elements. So 1 is 1 and it is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 4 and 5 is connected to 6, right? So 1, 1, 2, 3, 4, 4, 5, 6. This is the answer, and this is what this question is, that you need to return this is the linked list, right? So how we can do this? So the first would be, that is very intuitive, that and that is to store all these values in a vector. So if we store all these values, then it will be 1, 4, 5, 1, 3, 4, 2, 6, right? And after storing it into a vector, we can sort them, and after sorting it, it will be as the answer 1, 2, 3, 4, 4, 5, 6, right? So this is one way of using a vector plus sorting. So second way is using a priority queue. Instead of sorting it manually, we can store these values in a priority queue. So this is a priority queue, and if we have, let's say we are storing these values, iterating on these lists, and we store these values as 1, right? The next value is 4, fine. The next value is 5, okay. Now the next list, so it is 1, so 1 will be stored here, and then we have 3, so 3 will be stored here. And so now you're getting the point that these values will be stored in a sorted fashion. And for this particular feature, we can use a min heap, and we can extract the minimum element at every top from the top of the priority queue and use it. So priority queue is the second solution, and we can use that priority queue element, right? Now the third solution is, so this solution, why did this? I think the overall time complexity will be similar, and it might be a little bit slower than the vector one or the priority queue problem, because we are given sorted list, so we can use that to our benefit. But in either of the way, I think this is a very interesting solution. So if you are familiar with this problem, that is merge two linked list, then if you are not familiar with this, then I can explain you that this is 1, this is 3, and this is 5, and the another one is 2, right? So these are two linked lists, L1 and L2, and the problem says that you need to merge these two linked lists. So how do we merge it? We call a recursive function. So for 1, so the pointer is pointing on this element, right? So head pointer is on this element currently, and the links will be changed. So it will be pointing on this one, and 1 will be pointing on this one, and 2 will be pointing on 3 and 5. So this is how this linked list is now, and it is 1, 2, 1, 2, 2, 2, 3, and 2, 4. So if you are wondering how are we solving this, the implementation is based on recursion. You can also solve it with the help of a stack, but I think that recursive one is more easy. Recursive one has a better code, and it's just easy to implement, let's just say it. Now we are going to merge two linked lists. So for example, we are given k linked list, right? So we have 1, 2 up to k linked list. How we will do this? We will merge these 1 and 2. So 1 and 2 will become, let's say 1 and 2 will become x. Now we have 3, 4 and 5 and up to k. Now we will merge x and 3, it will become y, and y 4 and 5, and then we will merge this one. So this is how we will keep on merging it till in the list or the data structure that we are using, we are only having one, we are only having one list, and that is 5. So if we only have one list, then we will return the pointer that is the head pointer of this 5 link list. So let's implement this. So before implementing it, let me give you some let me give you a recursive tree diagram. So we have 1, 4 and 5. Okay, I will directly draw the linked list. So we have 1, 4 and 5. So what I will do is I will just explain you how these two linked lists are merged with the function. So if you will be able to understand the merging of these two linked lists with the recursive code that I'm writing, then you can easily understand how other lists are merging and so on. So here we have 1, 3, 5. This is the linked list, right? So at solve function, I will call their head pointers, right? So now I have 1 and 1. Now this will say that, so 1 and 1 are equal. In this case, I will keep a particular preference that if both of the elements are same, then merge the first element. I will say that in this case, I will say that the 1 from this first element, let's say the second element 1 is this one, right? So from 1, now give me the merge linked list. So my s function comma y as a head is promising me that I will return you the head of the merge linked list, right? So at 1 pointing to the other element, it will say that I will return you the linked list of the merge linked list, and we are sure that in this merge linked list this one will be there, and for the remaining part we will call this recursive function. And the remaining one is, so we were using this one, right? And now we will move to the next element, and that is 4, and that is 4, and this one will be as it is, this one as it is, right? Because we are not using this one, so this one will be as it is. Now from this function, now this function will be called, and this function will say that 4 and 1 is smaller, which means 1 will be there in this part of the linked list, right? Because now let's forget about this part. So this function is now reduced to 4, 5, 1, 3 and 5, right? So now you can clearly observe that when the linking will be done out of these two elements, this element will be at the first position, and then there will be the second smaller element out of these elements in the linked list, in the merge linked list. If this is the merge linked list, then this element will be on the first. So that is why we are putting this one as here, and even though it's the second linked list, and we will call recursively for. Now if we have this one, then this part is now reduced to 1. So now we have used 1, right? Which means now we have to pick from these remaining elements, and from these remaining elements you can clearly see that we have 4 here. You can clearly see which one is smaller. 3 is smaller, which means after 1, so let's forget about 1. So if this is the linked list only, then 3 will be there, right? So I will say that 3 here. Now, so from this linked list, now I can say that the smaller one, that is 3, so 3 will be there, and solve for the remaining part. Now let's erase them. Now yeah, so now we have 4 and 3, right? Out of these 4 and 3 will be used. So we have 4, and after 3 we have 5. And at this point I will say that 4 is the smaller one, so 4 will be at the start of the merge linked list, and out of these two values I will say that solve for the remaining part. Now after 4 we have 5 comma 5. As I've told you earlier, if we have both of the elements same, then I'm going to give preference to the first element, and we will move on the next part of the first element. And in this case we don't have a first element, so this is null, and this is 5, which means if each of the element is null, then it means the next elements or because the lists are sorted, which means that the remaining elements in the second or first list in the other list will always be greater than the last element of the merge linked list, that is the 5, which means that all the elements in this remaining list, the list 2, will be attached to the current last part of the merge list, which means this will return 5 or the head of the, or the remaining, or the node, the next node of the other linked list. So you can see the linked list will look like somewhat. Yeah, so the linked list will look like, so now we are getting one, from one we are getting another one, this type of one. From this one we are getting 3, from this 3 we are getting 4, and yeah, so from this 4 we were getting 5, and from this 5 we are getting 5, right? So initially we had this list, and now this list is merged. Now this list is merged. And now I'm going to compare this list, the merged list, with the next element, that is 2 and 6. And I think it's not required for me to draw this again. Even if you want to like try it out, then you can try this diagram, draw this diagram yourself. But now I think it makes sense how these things will be done. And yeah, so for this process, right, that I will keep on storing the list and so on, I'll be using a queue. So for example, I have this L1, L2, L3 and L4, right? These are the list. So at first part I will say L1 and L2 should be merged. So if L1 and L2 are merged, then L3 will be there, L4 will be there. And this is now L1, L2, the merged linked list. Then I will say these two linked lists should be merged. So this will be like this will be like L1, L2 and L3, L4. These are the merged linked lists, and then I will merge them, and this will become L1, 2, 3, 4, all of the merged linked lists, and it only has one element, which means this is the merged linked list that we have now with us. So let's solve this problem. So first I will say that if the list dot size is equal to 0, so if it is equal to 0, then we'll simply return the null value, right? Should we return the null value? Yeah, I think we should return the null value. And if list dot size is equal to 1, in that case I will simply return the first element, that is the 0th element of the list. And so with these out of the ways, because these could be the problems. Yeah, so if this is, which means that if this value is okay, now list dot size is equal to 1, but it has a null value, so we'll return null. Yeah, it makes sense. Now I will use a data structure called queue, and this queue will have the pointer of the list node pointers. And so queue is going to have some values, right? And these values will be I is equal to 0, I is less than list dot size, I plus plus, and q dot push the lists of ith character. So the ith character will basically be the pointer, the head pointer of the ith list. And yes, now what? So now what I will do is, if q dot size is greater than 1, right? If it is greater than 1, then I'll keep on doing this operation, and that is int list1 is equal to q dot front, pop this list out. Then I have list2, that is q dot front, and q dot pop this list out as well. And then I will say that int merge list is equal to, not int, it should not be int, it should be list node, list node pointer. And the merge list is now going to be merge so merge list, just merge I think, and that is list1 and list2. Now this is a merge linked list, and I will say that q dot push this merge list, right? So at last we are only left with one element in the queue, and we can return that, and that will be q dot front. Now let's merge them. So this will be a list node because it's returning a pointer of the merge linked list. So it will be a merge function, and it will have first argument as a pointer L1, and the second argument will be L2. Now if L1 is null, then return the L2, which means the L2 elements. And if L2 is null, then return the L1 element, right? Yeah, so now what we are going to do is, now if L1 value is smaller than or equal to L2 value, right? In this case, I will say that L1 will be used regardless. L1 is there. So L1 next will be the merge of L1 next element, starting from this element and L2 as it is. And then I will return L1. Else, if the condition is opposite, which means the L1 value is greater than the L2 value, in that case, L2 of next, which is a smaller value, should be equal to the merge of L1 and L2 next, and return L2 here, right? I think it makes sense. And just for the, I think in C++14 it will give an error that we don't have a return condition in this function, so I will return null, although this will never be used because the comparison will be done here and this else condition will run regardless. So let me check if there's any error. Yeah, L1 is null, so return L1, otherwise return L2, return L1, L2 next, L1 next, values compared, we do have value, yes, size is okay, 0. I think it's fine. Let's see. Okay. Okay, it's fine. Okay, it gets accepted, but it is performing okayish. I mean, there are people who have their code running for a whole second. So I guess mine is little better. They are doing is, okay, they are manually like doing a 2-pointer approach. And I think I'll be doing good in memory wise. No, not so good. Yeah, the recursive stack, the recursive call stack is taking some space here. Erase, remove. Oh god, they have literally override the main function. Great. So yeah, so that's it guys. If you will ask me the time complexity of this one, then in order to sort these two linked lists, it will take order of n plus m time, right? If this is the size n and this is the size m. Similarly, now this linked list will become, so this will n plus m and this is n plus m size, right? And then we will sort them, and this is, let's say this is n, so this is 2n and this is n again. So size will be the number of the size will be size will vary because it depends on the size of the linked list. So let's say if there's a size of every linked list has a size of n and there are m linked lists, then it will be n cross m, right? So time complexity will be n cross m. And if you ask me about the space complexity, it will be order of n because we are using the queue which is storing the head pointers, and we are also using a recursion, but recursion is like it's using n plus m space or recursive stack, n plus m space the recursive stack at every iteration. So it will basically just be n only because it's basically it's popping out the function recursive, the call, the activation records as well while backtracking, so which is why it will only be n. So yeah, this is the question. Thanks for watching guys.